What if I told you that right now, buried beneath the frost line of your own backyard, there is enough heat to warm your entire home through the coldest months of the year, completely for free? Not a solar panel, not a wind turbine, not some experimental technology that costs hundreds of thousands of dollars, just the Earth itself, quietly holding warmth that has been there since the planet was formed. This is real. This is proven science. And for less than $300 in materials, ordinary homeowners are building their own underground tunnel heating systems and disconnecting from expensive gas bills forever. But here is where the story gets darker. For decades, this technology has existed. Engineers have known about it. Some governments have even funded research on it. And yet, you have never seen it advertised. You have never seen it promoted on mainstream media. You have never seen your gas company or your electric utility company explain it to you. Why? Because the moment you understand how this works, their business model collapses. Today, we are going to change that. To understand why this system works, you need to understand one fundamental fact about the ground beneath your feet. No matter what season it is on the surface, whether it is a burning July afternoon or a bitter January night, the temperature of the Earth below a certain depth remains almost completely constant. In most parts of the world, once you dig down just 8. To 12 feet, the ground temperature stays between 50 and 60 degrees Fahrenheit year-round. This phenomenon is called geothermal stability, and it is not a theory. It is a measurable, repeatable, scientifically established fact. The reason this happens is simple. The Earth's mass is enormous, and soil is an excellent insulator. The sun heats the surface during summer, but that heat takes months to penetrate deep into the ground. By the time summer's warmth reaches 8 feet down, winter has already arrived on the surface, and vice versa. The result is a natural thermal battery that is always charged, always available, and costs you absolutely nothing to use. Farmers have known this for centuries. Ancient civilizations built root cellars underground to keep food cool in summer and prevent it from freezing in winter. We have simply forgotten how to apply this ancient knowledge to modern home heating. Now here is the key insight. If you can move air from inside your cold home through a tube or tunnel buried in that warm ground and back into your home again, that air will pick up heat from the Earth as it travels. When outdoor temperatures are below freezing, that same underground air will arrive in your home at 55 or 60 degrees. That is not warm enough to replace your furnace entirely, but it is warm enough to dramatically reduce how hard your furnace has to work. And in milder climates, or with the right design, it can be warm enough to heat a well-insulated home on its own. The basic system is beautifully simple. You bury one or more lengths of large diameter pipe or a constructed tunnel in your yard at a depth of at least 8 feet, ideally 10 to 12 feet for maximum thermal performance. The pipe runs from an intake point in your yard, usually protected by a screened vent to keep animals and debris out, through the underground section, and then back up into your home through the basement or foundation wall. A small fan, often no more than a 100-watt unit, pulls air through the underground section and pushes it into the living space. As the cold outdoor air travels through the buried section, it exchanges heat with the surrounding soil. If the tunnel is long enough, typically between 30 and 100 feet, depending on the climate and the diameter of the pipe, the air arrives inside your home substantially warmer than it started. In many documented installations, outdoor air at 20 degrees Fahrenheit enters the tunnel and exits at 50 to 58 degrees. That pre-warmed air then either supplements a conventional heating system, reducing fuel consumption dramatically, or feeds into a secondary heat source like a small wood stove or heat pump that now has a much easier job to do because it is starting with 50-degree air instead of 20-degree air. The materials are inexpensive and widely available. Corrugated agricultural drain pipe, concrete culvert sections, or even large diameter PVC pipe can all be used. A small electric fan costs almost nothing to run. The trench can be dug by hand over a weekend, or with a rented mini excavator in a few hours. Total materials cost for a functional system typically runs between $200 and $400. Labor, if you do it yourself, is just your time. This is genuinely accessible technology that any motivated homeowner can build. This is not theoretical. Across Europe, particularly in Germany, Austria, and Scandinavia, ground-to-air heat exchanger systems, which is the formal engineering name for what we are describing, have been installed in thousands of homes since the 1980s. In passive house construction, these systems are considered a standard component. Studies conducted by the Fraunhofer Institute in Germany documented systems that reduced heating energy demand by 20 to 40% in climates with hard winters. Canadian researchers at the National Research Council documented similar results in prairie climates where outdoor temperatures regularly fell to minus 20 Celsius. In the United States, the technology has been largely ignored by mainstream construction and heating industries, which is not a coincidence, as we will discuss shortly. But individual homesteaders, off-grid builders, and energy-conscious homeowners have been quietly building these systems for decades. Online communities dedicated to natural building and sustainable homesteading are full of first-hand accounts from families who cut their heating bills by 30, 40, even 60% after installing a ground air tunnel system. These are real people in real climates reporting real results, not laboratory simulations or ideal condition projections. One particularly well-documented case involved a family in rural Vermont who built a 60-foot buried pipe system at a cost of $280 in materials. They tracked their propane consumption before and after installation over 3 consecutive winters. Their average annual propane use dropped by 38%. Over 5 years, the system paid for itself more than 12 times over. The family estimated lifetime savings of over $40,000 if they remained in the home for 20 more years, from an initial investment of less than $300. Here is where we need to have an honest conversation about why this technology is not on the front page of every home improvement magazine, why your contractor has never suggested it, and why your gas company has never once mentioned it in any of the pamphlets they mail you about saving energy. The answer is uncomfortable, but straightforward. This technology directly threatens one of the most profitable industries in the world. The natural gas industry in the United States alone generates hundreds of billions of dollars in annual revenue. The heating fuel market, including propane, heating oil, and natural gas, represents a dependency that millions of households have been locked into for generations. Utility companies have spent enormous resources lobbying local governments to require that new construction connect to gas infrastructure. In many municipalities, zoning codes and building regulations were quietly written in ways that made it difficult or impossible to build homes without connection to centralized utility networks. This was not accidental. This was deliberate industrial policy designed to eliminate competition from decentralized energy sources. The phrase made illegal in our title refers to something very real that has happened in multiple jurisdictions. In some regions, building codes were written to classify any unconventional heating system as non-compliant, requiring expensive inspections, permits, and certifications that effectively priced ordinary homeowners out of using them. In others, HO regulations, often quietly influenced by developer relationships with utility companies, banned modifications to homes that would reduce grid dependency. The result was a slow, invisible suppression of technologies that would have given households genuine energy independence. The good news is that in most rural and semi-rural areas, there are no regulations preventing you from burying pipe in your own yard and using it to heat your home. If you own your land, you have the right to use its thermal resources. The first step is to check your local building codes. Not to ask permission, but to understand what permits, if any, apply to excavation work on your property. In most cases, a simple underground pipe installation does not require any permit at all. It is no different from burying a drainage line or an irrigation system. Once you have confirmed you are in the clear, the planning process is straightforward. Measure the available distance in your yard from the intake point to the entry point at your foundation. The longer the buried run, the better. Aim for at least 50 feet, if possible. Determine the best depth given your frost line, which you can find from your county extension office or a basic internet search for your region. Choose your pipe diameter. 8 inches is a practical minimum. 12 inches gives better airflow. And calculate your materials list. Dig your trench, lay your pipe with a slight slope toward the house for drainage, connect your fan, seal your penetrations, and test your system. You do not need to be an engineer. You do not need a contractor. You need a shovel, some pipe, a fan, and a weekend. The information is freely available, the materials are available at any farm supply or hardware store, and the earth beneath your feet is already doing its job, storing heat and waiting for you to use it. We live in a world where millions of families struggle to pay heating bills every winter, where elderly people on fixed incomes choose between food and warmth, where families in cold climates are financially trapped by their dependency on fuel companies that can raise prices at will. And all of this is happening while the solution, a simple pipe buried in the ground using the Earth's own stored heat, sits unused beneath their feet. The knowledge we have shared with you today is not new. It is not secret. It has been known by engineers and researchers for generations. What has been missing is the will to share it widely, to put it in plain language, and to give ordinary people the confidence to build it themselves. That is what we are doing here. If this video gives even one family the information they need to reduce their heating bill, to gain a measure of energy independence, to stop being financially vulnerable to fuel price spikes, then it was worth making. Build the tunnel. Reclaim the heat that is already yours. And share this video with every person you know who has ever struggled to pay a heating bill, because that knowledge, freely shared, is the most powerful thing we have.